All right, we are ready for notes over 1C, which is power to a power. And then we're going to go ahead and combine notes 1D at the bottom to this video also, because after this last section you should be ready to put it all together. Okay, so for the first one, 5 cubed and then that whole thing is raised to the second power. When we say the words power to a power, what we mean is this first 5 to the third, that is a power because it has an exponent on it. And then we're raising it to another power because it has another exponent on it. So you would pronounce this 5 to the third squared, or 5 cubed squared. So it's a power raised to another power. What they're basically saying is that they have a 5 to the third, and then they have it all written out twice. So here's a 5 to the third written out twice. And again, if we were to write it all out, it would be 5 to the third, and then another 5 to the third, or 5 3 times, and then another 5 3 more times. So that would be a grand total, if you counted them all up, of 5 to the 6th power. What pattern do you see? Basically, I know we've only done one of these, but I hope that you can look at it and say, well, it would have been much easier to come back here and just take the 3 and the 2 and multiply them together. That would have given me my 5 to the 6th. So when it says what pattern do you see when raising a power to a power, the answer is the same base. Once again, the 5 stayed 5, so we'll keep the base the same. So same base, and the 2 exponents are multiplied. Okay, and a fancy way to say this is it's the product of the 2 exponents, but I hope you all know that product means multiply, the answer when you multiply. So now that we know that basically you can just take your power and multiply it by the other power, or the 2 exponents and multiply them, let's try this one. So 7 squared, and then that whole thing is to the 4th power. So the base stays 7, and 2 and 4 get multiplied, which is 8. So 7 to the 8th. Okay, pause the video and try the 2 your turns. Hopefully those are pretty easy, and then you can just push play again and see if you got them right. Okay, check your answer. 3 was our base in the first one, and then the 2 exponents are 3 and 3, so 3 times 3 is 9. In number 8, 6 is our base, and then the 2 exponents are 2 and 4, so when you multiply those, that is 6 to the 8th power. Okay, I believe we are ready now to put everything you've learned in 1A, 1B, and now 1C, and try a little bit of all operations. Alright, I'm going to be really honest with you guys. This whole putting it all together section is not easy. I know that part A was easy, part B was easy, part C was easy, but then if I say, okay, using all of those operations, solve all of these problems, this is where it gets a little tricky. So I'm going to work out these first 2, and then you can try the your turn ones, but again, I'll work those probably out too, even though you can pause the video in between. Okay, let's start with this first one. You still are going to do order of operations. So if we want to combine 5 minus 2, that is going to be 3, and we also still have the exponent to the 5th power on it. I'm just going to bring down times, I don't know why it doesn't like me doing little dots, times 3 to the negative 8th for now. And then I'm going to put plus, and then go ahead and combine your 5 plus 2 order of operations, which is 7, and then that has a to the 0 power. Okay, now remember, you can only do your little tricks that you've learned in A, B, and C if the numbers have the same base. So our 3's actually have the same base. So if you went back to lesson A, you might remember that if they have the same base, then you can take the exponents and just add them. So 3 to the 5th and 3 to the negative 8th, when you add their exponents, would still be 3, same base, but it would be to the negative 3rd. And then I hope you guys remembered that any number to the 0 power, 7 to the 0 power, is just 1. So now we have 3 to the negative 3rd plus 1. All right, I'm going to move all of this up here. Sorry. Okay, 3 to the negative 3rd plus 1. You cannot have a negative exponent. You have to make it a positive exponent. So the best way to do that is to flip it to the bottom of a fraction under a 1. So 1 is now on top, and now you can take this 3 to the negative third and flip it to the bottom as the denominator, and this time it becomes positive. So 1 to the now 1 over 3 to the now positive third. Once it becomes the denominator of a fraction, you got rid of that negative and it became positive. And then we've still got our plus 1. Okay, and then simplify anything you can simplify. We can simplify 3 to the third. So 1 over 3 times 3 times 3, which is 27. And then you've still got your plus 1. And then you can use a calculator, or hopefully you know that 1/27 plus 1 is just 1 and 1/27. So that's the total answer there. The most simplified answer there. Okay, let's look at the second one now. 3 plus 1 in parentheses, we can do that. 3 plus 1 is 4. But then you've still got squared on there, and that whole thing is raised to the third. And then on the denominator, you've got 7 minus 3, which is 4, and then you've got a cube to the third power on that. Okay, the next thing I would do is remember your power to a power lesson, and know that if it's a power raised to another power, that you can multiply those. So I'm gonna move this back up to the top again. So 4 is your base, and then you've got 2 times 3, which is 6, over 4 to the third. Okay, that's a 3. Oh, that's terrible. Okay, if you have the same base and you're dividing, you can subtract exponents. So 4 to the 6th divided by 4 to the third when you subtract is going to be 4 to the third, because 6 minus 3 is 3. And then you can simplify that. If you can give me a final answer, do it. So 4 to the third is the same thing as 4 times 4 times 4. And again, use a calculator or whatever if you need to, but 4 times 4 times 4 is 64. So that's the final answer on that one. Okay, it's a good time to pause the video and try the your turns, but I am going to actually work these out, because if you get a different answer, I want you to see how we got these. So go ahead and pause the video and try the your turns, and then I'll meet you back here in a sec. Alright, these worked out. On the top, on the numerator, 6 minus 1 is 5. Squared, keep your squared there, and that whole thing was raised to the second power. Over, on the bottom, 3 plus 2 is 5, and that whole thing was cubed. So I would first do power to a power and make that now 5 to the fourth on the numerator over 5 to the third on the denominator. Since it's a division problem and the bases are the same, you can just subtract exponents. 4 minus 3 is 1, so you have 5 to the first. And any number to the first power is just whatever that number is. It's like saying, you know, how many times do you have 5 expanded out? You only have it once. So the answer would just be 5. All right, last one. 2 cubed and then raised to another power cubed. We can take those power to a power and go ahead and multiply your exponents. So 2 cubed to the third would be 2 to the ninth. That's a 9, sorry. Be careful that yours doesn't look like 29. Mine definitely does right there, and that is 2 to the ninth. Minus, we can put the parentheses, we can solve down the parentheses. So 10 minus 6 is 4. That whole thing is to the third. And then times 4 to the negative fifth. All right, let's leave the 2 to the ninth alone for now, because it is not the same base. However, 4 to the third and 4 to the negative fifth is definitely the same base. So those we can do our little tricks with. The 2 to the ninth we cannot. So in fact, I'm just going to bring down 2 to the ninth and then bring down your minus. Let's go ahead and combine 4 to the third and 4 to the negative fifth. If you're multiplying, which we are, you can add the exponents. So our base will stay the same. 4 is going to stay 4. But we're going to add 3 and negative 5, which is negative 2. All right, I'm going to keep 2 to the ninth again, and I'm going to put minus. Remember, you cannot have a negative exponent. Can't. You have to make it positive. And the only way to make a negative exponent positive is to flip it to the bottom under a fraction, under a 1, and it becomes positive. So it's still 4 to the second, but now it's no longer 4 to the negative second. It's on the denominator of a fraction, so it's 4 to the positive second. I'm going to rewrite this way over here. So I've got 2 to the 9th minus 1 over 4 to the second. All right, now let's go ahead and start simplifying down anything you can. So 2 to the 9th, that's 2 times 2 times 2 times 2 times 2 times 2. I don't know how many times I've said it, but 9 times. Which I would probably go ahead and get out a calculator, but it ends up being 512 minus 1 over 4 squared is like saying 4 times 4, which is 16. And I know it seems crazy, but you actually can combine 512 minus 1/16. So just put it in your calculator, or hopefully you know that 512 take away a little bitty piece, 1/16, would leave 511 and 15/16. And that would be our final answer.